So for our first part of 5.4 trig functions of real numbers, we really are just reviewing the unit circle again. So if you look here at the top, they tell us but didn't label everything on the picture at the bottom. They divided the unit circle into 12 equal arcs. So all of these different values here. So this basically was counting off by pi over 6. So we start with pi over 6. Pi over 3 is 2 pi over 6. Just reduced, 3 pi over 6, and on, just reduced. So having the unit circle in front of you, this is then just a matter of remembering some of these trig functions and what to do with them. So using the xy coordinates, and they gave us the coordinates for all of these points already. We can see which ones are positive, which ones are negative as we work through. And then it's remembering that it is the cosine of the angle for the x-coordinate and the sine of the angle for the y-coordinate. So whichever one you're asked to find, that's just telling you where you're looking for x comma y. So if for number 5, I want the sine of pi over 6, then I am just looking to the y-coordinate for pi over 6, which is 1/2. And that is it. For number 6, I'm looking at the sine of pi over 3. The y-coordinate at pi over 3 is the square root of 3 over 2. For number 7, I switch to cosine, so I'll be looking at the x-coordinates now, of 5 pi over 6, which isn't labeled, but if we, again, take a look, I have pi over 6, that would be 2 pi over 6, 3 pi over 6. My 4 pi over 6 here would actually end up being 2 pi over 3. And then 5 pi over 6 is this one here right before I get to my x-axis. So the cosine at pi over 6, that's my negative square roots of 3 over 2. Get out of here, keyboard. Number 8, the cosine at 2 pi over 3. I just labeled that one as well. So the cosine at 2 pi over 3 is simply the x-coordinate, so it's negative 1/2. And then we jump to tangent. So the tangent of pi, remember, is sine over cosine. So the sine divided by the cosine, which would be the y over the x. And so I have at pi here on my axis 0 divided by negative 1, which ends up being 0. So at pi over 2 pi, 3 pi over 2, and 2 pi, all of those angles, we're going to end up with either a 0 or an undefined. For number 10, the tangent at 0. So again, all the way back here, this would be my 0 or my 2 pi. And so y over x, because that's sine over cosine again, so I still have 0 over 1. So I'm still at 0. For number 11, we dip down into the third quadrant. The cosecant, remember, is the reciprocal of the sine. So when I'm asked for the cosecant at 7 pi over 6, I really need to find the sine of 7 pi over 6 and take 1 divided by that answer. So 5 pi over 6 pi, this is my 7 pi over 6. 8 pi over 6 would be next, but that's written as 4 pi over 3. This is 3 pi over 2, which is 9 pi over 6. 10 pi over 6 is really 5 pi over 3, and then 11 pi over 6 is my last one. Which, again, with a unit circle in front of you, all of that is labeled and should be good. So 12, I'm sorry, still on 11. 11 is the reciprocal of the sine. So if it's negative 1/2, then I'm really looking at 1 over negative 1/2. And when you multiply fractions, when you divide fractions, you multiply by the reciprocal. And so that actually ends up being negative 2. For number 12 now, the cosecant at 4 pi over 3. So again, 1 over the sine at 4 pi over 3. This time the sign is negative square roots of 3 over 2. So again, if I take 1 and multiply by the reciprocal, then I'm multiplying by negative 2 over the square root of 3. So we don't normally leave it with the radical in the denominator, but we didn't get to practice a whole lot of what's called rationalizing the denominator, which is just fancy for multiplying by whatever is underneath the radical sign because it gets rid of it. So multiply straight across negative 2 square roots of 3 in the numerator, but then the square root of 3 times itself, it's either thought of as the square root of 9 or it's the square root of 3 squared. Either way, it breaks down to just 3. So if you were to check answers, see them online in proper form, that's what it would look like. It wouldn't be negative 2 over the square root of 3. It would be rewritten as negative 2 square roots of 3 over 3. Doesn't necessarily make it look any neater or easier, but it is. Secant of 11 pi over 2. The secant is the reciprocal of the cosine. Sorry, 6. And so if I look at the cosine for 11 pi over 6, the x-coordinate, if you will, it's square root of 3 over 2. And so the same thing is going to happen. It's just going to be positive instead of negative. So it's going to be 2 square roots of 3 over 3 if I do the exact same work for what I had there at number 12. 14 is another secant. So the secant at 5 pi over 3, 1 over the cosine is 1 over 1/2, which again, multiplied by the reciprocal would be 1 times 2 over 1, which is just my 2. Getting back to some easier ones, 15 is the sine of 3 pi over 2. And so the y-coordinate at 3 pi over 2 is negative 1. And then 16 is asking me for the x-coordinate there. It's the cosine of 3 pi over 2, which is 0. 17, if I'm asked for the secant at 3 pi over 2. 1 over the cosine, which I just found to be 0, is undefined because I'm not allowed to divide by 0. And last but not least, number 18, the tangent at 3 pi over 2 is sine divided by cosine. So again, if I have negative 1 and I'm dividing by 0, this is actually undefined. So this is why knowing and having the unit circle as a reference is so important. And at some point in the future, some of these you are just expected to know, or if you don't have the unit circle in front of you, take a minute or two to visualize where these things would be and to come up with these exact values. So instead of just making sure your calculator is in radian mode and plugging all of these in, this will get you the exact value for these trig ratios.